Hello students, in this video we are going to look at the questions asked in JEE Advanced 2020 from the chapter complex numbers. So they have asked two questions, one in each paper. So in paper 1, this is one or more than one correct answer type question. So this is a very good question. And this is the question asked in paper 2. Like this is also based on complex numbers. So if you wish, pause the video and give them a try. Okay, now let us look at the solutions of these questions. Okay, the first question is this. Let S be the set of all complex numbers z satisfying this equation modulus of z square plus z plus 1 is equals to 1. Then which of the following statements is or are true? So if you look at the first three options, they are based on inequalities. So from this we'll get a hint that we can use triangle inequality. And the fourth option is slightly different. The set S has exactly 4 elements. That means he is asking us number of solutions to this equation. So now first let us look at option D, the fourth option. After that we will discuss about the first three options. Looking at option 4, he is telling exactly 4 elements. The intention of the question setter might be that some students may take this modulus as just like modulus of a real number, open it with plus or minus sign, then we'll get 2 quadratic equations and solving them will get 4 solutions. Some students may think like that and answer option D as correct option. But that is not the case because this is actually a complex number, isn't it? Z square plus z plus 1 is a complex number because z is a complex number. A complex number whose magnitude is 1. For this equation, there are infinitely many possible solutions. Like for example, 1, magnitude of 1 is 1, magnitude of minus 1 is 1, magnitude of iota, that is also 1, magnitude of minus iota, that is also 1. This complex number z square plus z plus 1 can have infinite possibilities. Suppose if we have, let's say, z square plus z plus 1 is equals to 1. So if you solve this, we'll get z equals to 0 comma minus 1. And similarly, if you take z square plus z plus 1 is equals to minus 1. So bringing this minus 1 to LHS, we'll get z square plus z plus 2 is equal to 0. Solving this, we'll get z equal to minus 1 plus or minus root 7 iota by 2. So there are 4 solutions. Now apart from this, z square plus z plus 1 can be iota as well because we know magnitude modulus of iota is 1. So if you take this z square plus z plus 1 is equals to iota. So solving this, suppose if you bring this iota to LHS, we have z square plus z plus 1 minus iota equals 0. Now we can factorize this. We have z square plus 1 plus z minus iota equal to 0. If you factorize this we can write it as z plus iota into z minus iota plus we have z minus iota is equal to 0. Now taking z minus iota common, we have z minus iota into z plus iota plus 1 is equals to 0. This implies z is equals to iota comma minus 1 minus iota. These are the 2 possible values. Similarly, if we take z square plus z plus 1 is equals to minus iota, similarly we can solve this as well. Solving this, we'll get z is equals to minus iota comma minus 1 plus iota. In fact, not only this 1 minus 1 iota minus iota, we can in fact take any complex number whose magnitude is 1. So we can take even like this z square plus z plus 1 is equals to 3 by 5 plus 4 by 5 iota. So you see the magnitude of this is also 1. So like this we can have infinitely many possibilities. So we can combine them all and write it like this. We can write them as z square plus z plus 1 is equals to e power I theta, where theta goes from minus pi to pi. For different values of theta, we will get different values of z, and all of them will satisfy this condition. For example, the cases which we have written here are nothing but special cases. When we take theta equals 0, we will get this one. When we take theta equals to 180 degrees or pi, we'll get this one. When we take theta as 90, pi by 2, we'll get iota. When we take theta as minus pi by 2, we'll get minus iota. And if we take theta as 53 degrees, cos 53 degrees plus I sine 53 degrees, we'll get this. So that means for every theta, we are going to get two solutions. And there are infinitely many possible values for theta from minus pi to pi. So therefore, this equation will have infinitely many solutions, right? So the complex numbers present in the set S, the number of complex numbers present in the set S are going to be infinitely many. So that means option D is incorrect. Now, looking at options A, B and C, we know that we can use triangle inequality because they are dealing with inequalities. So now, if you observe closely, let's say for option 1, these two will satisfy, right? So 0, if you substitute, it is magnitude of half is less than or equal to half, and even if you substitute minus 1, it will satisfy. But if you substitute this one, iota or minus 1 minus iota in the option A, so here if you substitute iota in this, in option A, it is going to be magnitude of iota plus half. That is going to be magnitude of iota plus half is actually root over 5 by 2, because root over 1 square plus half square, that is root over 5 by 4, that is root 5 by 2, which is greater than half. So that means iota satisfies this condition, whereas it doesn't satisfy option A, right? It doesn't satisfy option A. That means from this we can say option A is incorrect, because it is telling for all z belongs to S, because iota is one of the possible solutions. Iota will be present in S, but for iota it will not be less than or equal to half. So from this we can say even option A is also incorrect. Now let us look at option B and option C. Now for option B and option C, let us try to use triangle inequality. So if you observe carefully, z square plus z plus 1, z square plus z plus 1 can be written as z plus half whole square, isn't it? If we complete the perfect square, we can write this as z plus half whole square plus 3 by 4. So let us do it. We can write this as, this one as z plus half whole square, z plus half whole square plus 3 by 4 is equals to e power I theta. Now from this, so we have, this implies we have z plus half whole square is equals to e power I theta minus 3 by 4. Now taking modulus on both sides, what we have is modulus of z plus half whole square is equals to modulus of e power I theta minus 3 by 4. Now applying triangle inequality on this, we will easily get the range of z plus half, modulus of z plus half. So now what does triangle inequality say? Triangle inequality says that modulus of z1 plus z2 is always less than or equal to mod z1 plus mod z2, and this is always greater than or equal to modulus of z1 minus modulus of z2 whole modulus. In fact, even we can have minus also over here. We have like this. So these are triangle inequalities. If we apply triangle inequality on this, we can directly get the range of this quantity. Thereby we can directly get the range of this z plus half, magnitude of z plus half. So let us simplify a bit before going further. We can write this as z plus half whole square, magnitude of z plus half whole square, because we know modulus of z square is same as mod z whole square, that is equals to magnitude of e power I theta minus 3 by 4. Now applying using the second result, we can say modulus of e power I theta minus 3 by 4 is less than or equals to modulus of e power I theta plus modulus of 3 by 4 greater than or equal to modulus of e power I theta minus modulus of 3 by 4. So this is nothing but, so this is less than, so modulus of e power I theta minus 3 by 4. This is nothing but 1 and this is nothing but 3 by 4. So 1 plus 3 by 4 is 7 by 4. And this is 1 minus 3 by 4, that is going to be 1 by 4. Modulus of 1 by 4 is same as 1 by 4. So therefore from here what we have is, therefore we have 1 by 4 less than or equal to modulus of z plus half whole square less than or equals to 7 by 4. So therefore taking square root, so what do we get? Taking square root, we will get 1 by 2 less than or equal to modulus of z plus half less than or equal to root 7 by 2. Therefore from here we can easily say that modulus of z plus half is always greater than or equal to half for all z which satisfy this condition. Therefore option C is correct. We can also arrive at this conclusion using geometrical interpretation. Instead of using triangle inequality, we can also obtain this by using geometrical interpretation. So how we can obtain? So e power I theta is nothing but a point on circle of unit radius whose center is origin, and 3 by 4 is nothing but a point on real axis. So let us, if you look at geometrically, so we have a circle with radius 1 unit. So this is 1 unit. So this is, let's say, organ plane, x-axis, y-axis, and now so e power I theta is going to be any point on this, e power I theta cos theta plus I sin theta, and we have 3 by 4 over here. So this is going to be 3 by 4, 3 by 4 comma 0. Modulus of e power I theta minus 3 by 4 indicates distance between this e power I theta, that is cos theta comma I sin theta, that is nothing but cos theta comma sin theta, that point, and the point 3 by 4 comma 0. So this distance, so the modulus of e power I theta minus 3 by 4 will actually give us this distance. So that is this distance. So now the least possible distance, so the least possible distance is going to be this. This is going to be the least possible distance, that is 1 by 4. And the greatest possible distance is going to be this, that is 7 by 4. So this is nothing but, so this is nothing but 1 by 4. And this is nothing but 7 by 4. From here also we can understand that modulus of e power I theta minus 3 by 4 lies between 1 by 4 and 7 by 4. Okay, now once we have this, now the next part is, option B. Option B talks about mod z. So we are looking for the value of z, mod z. So now again we can use triangle inequality here on this. Suppose if I apply triangle inequality on this portion, so we have mod z minus modulus of half whole modulus is less than or equal to mod z plus half is less than or equal to root 7 by 2. So now from this, so considering this one and this one, so we have, what we have is, so modulus of z minus half modulus of this is less than or equal to root 7 by 2. So simplifying, we'll get minus root 7 by 2 less than or equal to mod z minus half is less than or equal to 7 by 2. Now bringing this half on, adding half on both sides, so we'll get minus root 7 plus 1 by 2 is less than or equal to mod z less than or equal to root 7 plus 1 by 2. So from here, so root 7 plus 1 by 2 is actually less than 4, because we can say root 7 is less than root 9. So root 9 plus 1 by 2, root 9 plus 1 by 2, which is nothing but, this quantity is nothing but 3 plus 1, 4 by 2, which is nothing but 2. So therefore we can say mod z is in fact strictly less than 2, right? Even if option B is like this, we can say it is correct, but they said mod z is less than or equal to 2, that is also a true statement. So B is also correct statement. Mod Z is less than or equal to 2 for all Z belongs to S. Therefore, the correct answers are, answer is option B and option C. Now next, let us look at the second question. So this question is single digit integer answer type question. So the answer is going to be an integer between 0 to 9, including 0 and 9. So the question is this: for a complex number Z, so okay, this denotes the real part. Let S be the set of all complex numbers satisfying this equation, where I is root over, iota is root over minus 1. The minimum possible value of modulus of Z1 minus Z2 whole square, where Z1 and Z2 belong to S. That means Z1 and Z2 are complex numbers satisfying this and also these conditions. Now if you look at this equation, so we have Z power 4 minus mod Z whole power 4 is equals to 4 iota Z square. So we have a standard result. We know that Z into Z bar is equals to mod Z square. So if we use this in place of mod Z whole power 4, we can write it as ZZ bar whole square. So replacing this with ZZ bar, so Z power 4 minus Z into Z bar whole square is equals to 4 iota Z square. Now the reason for doing this is we can take Z square common from all the terms, so it will get further simplified. So Z power 4 minus Z into Z bar whole square minus 4 iota Z square is equals to 0. Taking Z square common, what we have is Z square minus Z bar square minus 4 iota is equals to 0. So therefore we have Z square is equals to 0, and we have Z square minus Z bar square minus 4 iota is equal to 0. So this gives us Z is equal to 0, which we are anyway not interested, because we are looking for solutions where real part is greater than 0 and real part is less than 0. So for here real part is 0. So now let us solve this. So if you solve this, let's say Z is equals to x plus iota y. So we have Z square as x square minus y square plus 2 iota xy. And now what about Z bar square? That is nothing but Z square whole bar. That is going to be x square minus y square minus 2 iota xy. Now Z square minus Z bar square, that is going to be 4 iota xy. So therefore we have 4 iota xy minus 4 iota is equals to 0. So this implies we have xy is equals to 1. So xy is equals to 1. That means, so the complex numbers which satisfy this equation in the argand plane lie on this xy equals to 1, and which we know that this is actually a hyperbola, rectangular hyperbola. Xy is equals to 1. So this is one branch of the hyperbola and this is the second branch of the hyperbola. So here he is telling that a real part, so any point which lies on this hyperbola will satisfy this equation, as well as origin also satisfies this equation. So the solutions for this equation are actually the origin and any point which lie on either branch of the hyperbola. Now he is telling Z1 and Z2 are two complex numbers which satisfy this equation. Real part of Z1 is positive. That means Z1 is going to be somewhere on this branch. Z1 is going to be somewhere over here. And real part of Z2 is negative. That means Z2 is going to be somewhere on this branch, Z2. Now we want that modulus of Z1 minus Z2, that is the distance between them, to be minimum, because modulus of Z1 minus Z2 gives distance between Z1 and Z2. If that is minimum, its square also would be minimum. We want to choose Z1 and Z2 in such a way that they are closest. So now if we, by symmetry, we can easily understand that. So the shortest distance will be along the common normal, and in this case the common normal to both the branches is nothing but the transverse axis of the hyperbola, that is going to be this one. So if we take Z1 as here, Z1 as 1 comma 1, that means 1 plus iota, and if we take Z2 as minus 1 comma minus 1, that is minus 1 minus iota, then in this particular case the distance between them is going to be least, because this is the transverse axis, it is normal to both the branches. So we can easily say that, so therefore modulus of z1 minus z2 minimum 1 minus of minus 1, that is 2, 2 square plus 2 square. So therefore modulus of z1 minus z2 whole square minimum is equals to, that is 2 square plus 2 square, that is 4 plus 4, that is 8. So therefore the answer to this question is 8. So that's it for today. Hope you liked these questions. See you in the next video.